Hey everyone, Mr. Aarons. We're jumping into 6.2 today. This one should be a pretty quick lesson, especially compared to yesterday, and I hope a lot easier. Yesterday, I think, is one of the toughest units of this chapter. This unit, I don't think will be quite as bad for you. Today, we are working on 6.2 proportions. So we're talking about ratios, which is basically just comparing something like, an example I gave yesterday was 10 apples. I think I said apples to onions. 10 apples to 15 onions, saying for every 10 apples you had 15 onions. Today we're going to be working on proportions, which is going to be like comparing those. So I could say 10 apples for every 15 onions, or 5 apples. That's not going to work very well. Let's do 3. Let's divide by 5, and let's do 2 apples. 2 apples for every 3 onions. And if you notice, these are equivalent fractions. This is going to be the same as 2/3. If we just divided each of these by 3, we would get this right here. So those are going to be two equivalent proportions, is what we're going to call those. So I have a proportion over here, and really all that is, like I said, it's two equal ratios. So right now I have 6/9 is equal to 12, or 8/12. Both of these are really equal to 2/3. We could divide both of these by 3 to get 2/3. We could divide both of these by 4 to get 2/3. So these are two equal ratios. That's what a proportion is. That's all you need to know. It's two equal ratios. With equal ratios, we can do something called the multiplication property of equality. I'm not super stressed on you knowing what that means, but I'm going to tell you this right now so you can understand why it works. So here's our rule: is if we have A over B and that's equal to C over D. So just like up here, if these are equivalent, then A over B times B times D is equal to C over D times B times D. And you might be thinking, why is this important? That doesn't make any sense. But basically what this means is it allows us to do something called cross products. This is going to be something that you've heard of maybe called cross multiplying. Sometimes you'll get this confused with when you're supposed to be multiplying and dividing fractions, but you really only do this when proportions are equal. So here's our key right here. If you're going to put one thing in your notes today, this is what I want you to put in your notes. Our key is if two proportions are equal, then so are their cross products. If we have two proportions that are equal, then so are their cross products. Let me show you what that means right here. So if we have A over B, and that is equal to C over D. So like up here, how these two are equal, if we have a situation like that, then we can cross multiply, and those two answers should also be equal. So our A times D, these two cross multiplied, and these two should be equal to each other. Let's try it up here with this one. So if I cross multiply up here, multiply those two, and this two, and I know that 8 times 9 equals 72, and I know that 6 times 12 equals 72. And those are equal. So this is an example of if you have two equal fractions and you cross multiply, those are always going to be equal. We have a few more examples of that right here. I'm going to do one more. If I have 3 halves and they tell me that that's equal to 6/4, cross multiply those, and we'll do 3 times 4 and 2 times 6, and we'll get 12 equals 12. Why is this important? Because sometimes when we're solving a problem, we're not going to have everything in the fraction. So I know that these are equal right here. Take a look at this one. I know that they're equal. So here's what I'm going to do. I don't know what x is, but I can cross multiply. Watch how this is going to work out. One side is going to have 9 times 4 is going to be 36. 9 times 4 equals x times 6. 36 equals 6x. Now I can solve for x. All I have to do is divide each side by 6, and I'll figure out that x equals 6. I cross multiplied and then solved. This is going to be our key for today. Here's another example. Cross multiply here. One side we're going to get 5 times t, and then that's going to be equal to 55 times 4. Let's see, that's going to be 220. Divide each side by 5. 220 divided by 5. I think that's going to be 24 maybe. 44. So then we would get t equals 44. Again, we're taking these equal fractions, cross multiplying. These equal proportions, cross multiply. One side we're going to get 6d here. The other side we're going to get 22 times 21. 22 times 21. And I get 6d equals 462. Divide each side by 6 to get d by itself. And we get d equals 77. So basically what happens here is if we have a variable in there, we can cross multiply, and this is going to set up an equation that we can solve easily. We can also test if two fractions are equal by doing this same thing. We're going to set them equal to each other and see if they would multiply to be the same. So what we're going to do right here is we're going to take 6 times 9, or 6 over 9, and set that equal to 4/6. Now all we have to do here is cross multiply. And I'm going to do 9 times 4 is going to be 36. And my other side, 6 times 6 is going to be 36. So these are equal. Checks out. They're both equal. Take a look at our next one. Let's cross multiply. See if they're equal to each other. 20 times 5 is going to be 100. 15 times 7, that is going to be 105. Those are not equal. Not equal to each other. These ones would be equal to each other. One more here. Cross multiply. 2 times 3, we're going to get 6. 7 times 1, we're going to get 7. Those are not equal to each other. So basically, you can test if two fractions are equal to each other just simply by cross multiplying them. Super quick, super easy. Cross multiplying is the key today. A couple more examples, and then we're going to keep it nice and short. They tell us 100 nautical miles equals 115 statute miles. That's my ratio. 100 nautical miles is the same as 115 statute miles, so I set that up as a ratio right here. How many statute miles equals 381 nautical miles? All right, well, I'm going to put nautical miles up here just so I know where it's stat right here. And they want us to compare that to, I have to make sure I put the nautical miles in the same spot. So notice I'm putting nautical miles on top this time because they have to be equivalent fractions. This isn't like last time when we were converting fractions. We're not converting any fractions here. I should say statute. And we do not know this right here. We know how many nautical miles that would be. We don't know how many statute miles that would be. Again, if you're curious on a nautical mile and a statute miles, what you would just consider a mile. A nautical mile is kind of like a mile at sea. It's a little bit different. The conversion isn't quite perfectly, but that's about as much time I'm going to give you today. You can ask a history or science teacher if you're a little bit more interested on it. So right now, what am I going to do to figure out how many statute miles that would be? I'm going to cross multiply. This is our chance to do that. We're going to have 100x on one side, and the other side we're going to have 381 times 115, and that would be a big old number. Finally, divide each side by 100, and I know that's just going to mean I'm going to move the decimal place twice. And I was able to figure out right there that 115 statute miles, 100 over 115 is going to be the same as 381 over 438.15. I got one more example for this. If you're feeling a little confused, don't fret quite yet. If after this you're still feeling some confusion, be sure to come into my office hours. That's a great time to ask questions and for me to help you out, especially in those one-on-one situations. All right, so they tell us a sale sells 4 oranges and you get 5 free samples. So I have 4 oranges and I'll get 5 free samples if I get those 4 oranges. And they tell us if I got 45 free samples, how many oranges do I get? We don't know how many oranges. Remember, these are equivalent fractions. I'm going to keep them on top and the bottom's the same. I don't change those units across because we are only doing that when we are converting units. These are equal to, we're not multiplying them. Right here, in order to figure out some equivalents, let's cross multiply, and we'll get 5x on one side, and we'll get 45 times 4, 180 on the other, divide each side by 5. and x will equal 36. So I know that 4 oranges for 5 free samples is the same proportions as 36 oranges for 45 samples. These are going to be equivalent fractions. Basically, what we have been doing all day today is finding equivalent fractions by cross-multiplying. We can check those. If you have any questions, hop into my office hours. Hopefully this one isn't too tough for you. Have a good rest of your day.